Claire, can you hear me?
Yes.
I think this Google Meet is designed to not work with Safari because it has it kind of gets me in and does annoying things and then just crashes. So I think it's just meant to
I finally found a use for Chrome.
cause pain if you use Safari. It's an interesting tactic. All right, I don't know if we set an agenda today. We should have actually. But we can continue with the Helm based. I made some more progress. We can also look into some of the open issues. That's the second part. And we can discuss anything else that we want to discuss. So, and we can do this in any order. It's up to you folks. Hello?
I'm fine with any of those options.
Okay. So let's continue with the Helm experiment. In that case, I have something to share. It's still not ready. It's still, I'm pretty sure I made some mistakes in the templates, but we can still examine the Helm based option. All right. So sharing entire screen.
Quick question, folks. Sorry. Is it just me, or do you also need to ask to join the meeting?
Yes. Well, what do you mean by that? I have to admit people in.
Okay.
Is it okay for you to keep it like that? Is there another setting where you don't have to admit people in? It may be easier for you. All right, so Helm Experiment, right? If you remember, this is kind of how the Helm Experiment is intended to work. So this is going to be your first experiment, and there's the Helm repo. I just created a Helm repo using, Iter8 repo itself, GitHub repo. There's a way to use GitHub pages to create, Helm repo. That's what I did here. And I have a chart called deploy, and you can do a Helm install with this values file, stable.in. By the way, I'm not running it because it doesn't work yet. So if you're wondering why I'm talking about it and not actually showing it run, because it doesn't work yet. So apologies, it should work in a few minutes after this call. So I have a Helm chart and a values file, and I'm Helm deploying the actual application, the stable version of the application. And then I'm Helm deploying the candidate version of the application. When you Helm deploy the candidate, you also deploy the experiment. That's how this Helm everything works. Whenever each time you change the candidate, a new experiment will be generated. So, and then the rest is like you have observe experiment and you promote winner. This time when you promote winner, you basically, set the stable version. Once again, you update the stable version of your application. So let's start with the values file because that will kind of inform, before we get into the actual Helm chart, how it is designed and all that, let's get into the values file. So the values file is here. This is the stable version. So I have a Kubernetes service backed by a Kubernetes deployment, and I have a stable, and eventually I want to have a candidate version. Right now I have only a stable version. Some values make sense for the stable version, some values make sense for both the stable version and the candidate version. These are the values that make sense for both the stable and the candidate version. These are the values that make sense only for the stable version. Incidentally, this needs to be 80, that's why it's not working. The target port needs to be 80, that's why this thing is not working yet. So, okay, so when you deploy the stable version, this is what you supply. And when you deploy the candidate version, you just supply another something called candidate. And the only change, well, there are two real changes. One is there is a name change. I think this can also be taken out. But there is also a selector label, right? So you have a candidate version, so Kubernetes service for the candidate version needs to be backed by the Kubernetes deployment for the candidate version. So there's a selector label to make that work. And the only real change between stable and candidate in this example, in probably most examples, is the image that is used for building the candidate version. That's the only real change. So perhaps we can just pick out all this and put it as part of the template instead of having to put it in the values. So what's really going on from a CI/CD perspective, right? From a CI/CD perspective, each time there is a build pipeline trigger, build pipeline finished creating a new build, and it wants to deploy a new candidate, this is the part that it changes. And what is happening from an Iter8 version promotion perspective, each time there is the new stable version that Iter8 declares to be the winner, well, either it can, send a notification, or it can directly change this in a GitOps setting, maybe using a Git commit, it can directly change this stable version right here. And that's all. Once again, you go back to this file and you have a stable version. If your candidate succeeded, then your stable version will look like this. If your candidate failed, your stable version will look like this. This is the intent of structuring the values file this way. You have stable, you have candidate. Each time you have a new candidate, you update this section. Each time you want to promote, you eliminate this section and you change this to the appropriate value. Or in other words, you copy over the section to under stable and you take out this whole section. So that's the big idea of the Helm templating. The thing to really notice here is that so far the user needs to know Helm. The user needs to know, how to structure your stable and candidate versions. The user doesn't need to know about Iter8 experiments yet. There is some Iter8 experiment doing some checks, and if that experiment satisfies your needs, you don't have to do anything. You can start using it right away. That's part of the attraction, hopefully, here. Questions before you get into the actual chart and the templates? Hello?
Is there a play he or she between what you're showing and the new handlers?
Yeah.
Tasks?
Yeah, absolutely yes. Absolutely yes. There is a big play between what I'm showing you here and the new tasks. So there is some tasks. First of all, let's get into the experiment. Okay, so I will answer this question in detail a little bit. There are some new tasks that are already featured in the experiment that you see that are kind of important in a Helm setting like this, and more importantly in a GitOps Helm setting. Okay, so let's look at the existing experiment. Let's look at the task that it already embeds, and then we can come back to what other new tasks actually make sense in the context of Helm and in the context of GitOps. Okay, so going back to the Helm experiment, right? So so I said that, this is a simple Kubernetes service backed by a Kubernetes deployment. So here's how they are templated. Okay, so we got a this is the actual template for the baseline version, the stable version of the service, and this is the template for the candidate version of the service. And this section will be ignored. If you do not even have a candidate in your values file, for example, in the first values file that I showed you, which was here, there is not even a candidate section. So this whole thing is going to be ignored. There won't be a candidate service, there won't be a candidate deployment to speak of. Only the stable service and the stable deployment are being created. And there is no Iter8 experiment at this stage. This is just your plain old create an application using Helm. I have a service, I have a deployment, templated, get the values from the values file, period. That's all is going on so far. When you do have the candidate section in the values file, for example, if you use this values file, there is a candidate section. Then this part kicks in. The actual candidate service is created. The actual candidate deployment is created. And there is an experiment that is getting created. So automatically, each time you create a candidate version of your application, there is an experiment that is automatically launched by Helm. You don't have to do anything extra for launching this experiment because it's all bundled in as part of the chart. Now, what happens? So what's going on in this experiment, right? So let's take a quick look. Yeah, I have the candidate, so, the stable and the candidate services. I have the stable and the candidate deployment. Well, obviously I messed up something in the images, so it's not ready. Ignore it. kubectl get experiment. Minus YAML. Now let's look at the experiment.
What's this tag here, Sri? Sorry.
It's a plain Kubernetes. It's a plain Kubernetes without any service mesh, without any ingress, no anything. Just a service and a deployment. It's to demonstrate the concept of Helm Experiment. That's all it is.
Okay. And what's the experiment type in this demo?
Conformance experiment, a very simple experiment intended to check whether your deployment is satisfying some basic latency error rate metrics.
Mm-hmm.
If it is, it's intended to promote. If it is not, then don't promote. And even the promotion is not automated as per the experiment. You will check it and you'll promote it. That's the idea. Just to demonstrate the Helm experiment templating. Okay, so you asked this question about, are there new tasks in Iter8 that come into play? So the answer is yes, right? So we just recently created this new task called a readiness task. You see, in this case, in the Helm deployment case, a lot of things are getting created at the same time. The deployment is getting created at the same time as the service, as the experiment. So I don't want to just kickstart an experiment right away because the deployment may not even be ready. So I don't want the experiment to start until all the resources are created and are ready. So there is a reason task that we created precisely to check this as part of experiments. Don't start an experiment immediately. This will wait for 5 seconds, and after 5 seconds, it will just make sure that these services are present. This service is present, the stable and candidate service. We'll also check if this deployment is present. Optionally, you can even say, well, I don't want the deployment just to be present. I also want to check for a condition. I need it to be available, not just present. So check for that, and then start the experiment. That's what the common readiness task is actually doing.
So if you look at this,
yeah, sorry.
Go ahead. Go ahead.
Incidentally, I think I noticed.
So
this is actually this is inspired by the issue that you created. So if you remember, there was a metrics not being present when the experiment started issue, and quick hack was just wait for the metrics object to be ready. Now you don't have to. This is still a hack. You're still just doing a sleep before the metrics object becomes ready, but at least you don't have to hack up your CI/CD. You can put this readiness task in the experiment, and you can make it wait. And the wait period is, customizable, and then start the experiment.
If you're looking at this at the experiment specification, that task takes up as a parameter an array of object references, and I suppose it is going through all of them, making sure that the status is ready. Is that how this is working under the covers?
Yes and no. So some objects do not have a concept of ready or even a concept of conditions. So yes, it will check for the existence of objects. And optionally, if you specify for some readiness condition, it will wait for those it will check for those readiness conditions also.
If you have the wait for clause, then it does that. If you don't, just make sure it exists, the object exists.
Exactly. And additionally, the experiment itself has sometimes, wait object references for shifting weights and things like that. So you don't need to explicitly specify any of those things. As part of the readiness task, you can simply this thing will do the right thing. It will look for those objects also, make sure they exist before the experiment begins. If they don't exist, or if it keeps retrying, and the number of times you retry is all parameterizable. It's all part of task inputs. Here I just use the default values. So it keeps retrying, but at the end, if you don't find it, or if you didn't satisfy the wait for clause is not satisfied, it will just fail. It won't start the experiment. It will fail right then and there as part of the start. And at least, you're not going to get weird or unexpected results or behavior out of your experiment. So that's the idea of this task.
And if I have another task right after this one in the start action, I suppose that will kick in only after either this one succeed. If this succeeds and that it's done verifying that everything's ready. Is that correct?
Correct.
Okay.
Correct. So I do have another start action here. So I have a metrics collect start action, and that is collecting metrics for my Kubernetes deployment, and by just doing it, collecting latency Iter8 built-in Iter8 metrics. And that will not start until this readiness check passes. This task will not even begin. Right? So let's come back to your question about is there a play for other newer Iter8 tasks, right? So I think the answer is yes. So let's forget GitOps for a second. Let's just think through the regular CI/CD setup. Let's just say this is going to happen in some GitHub actions, let's say, okay? So imagine a GitHub actions pipeline, and imagine these things, sorry again. Imagine this Helm command run in a GitHub actions pipeline, right? So you install your stable version somewhere. You got a new candidate. You did a build pipeline, and you installed a new candidate. And that candidate is now getting Helm installed in some GitHub actions pipeline. So the whole experiment is getting started. There are a couple of ways to think about it. You fire and forget. So in your GitHub actions pipeline, you create this Helm, and it created an experiment, and that's it. The pipeline ends at that stage. So if that's what you did, then something needs to happen to actually, observe results and promote the winner, right? So the promotion of the winner can happen inside the, we are using Helm here. So you really should be using some sort of a Helm command to promote the winner also. Otherwise, you're just mixing up too many package management tools. Either Helm is in charge of your application or something else is in charge. In this case, Helm is in charge. So you have to use Helm if you really want to get it right to do the promotion also. So the way to do that would be you have a notification task in your Iter8 experiment. At the end of the experiment, it sends a notification to another GitHub Actions pipeline, and that gets triggered. And based on the content of the notification, the notification, will say what version won. It was the candidate version that won, or it was a stable version that needs to continue as a stable version. And based on that content, that will do the promotion. So that's one way of doing it. But if you have a very short experiment, for Kubernetes deployments, for simple experiments, if you're just taking latency error rates and some basic validation, you can do it fast. 5 minutes, send some requests, check your latency error rate, and do the promotion. You can do a busy wait as part of your pipeline, GitHub Actions pipeline. You don't have to wait for a notification, run the experiment, and do a busy wait for the experiment to complete, check which version won, and do your Helm upgrade of baseline or candidate right then and there as part of the GitHub Actions. That's also possible, but I think that's kind of, I would imagine that's not the common case. I think most real-world experiments might actually take a little bit of time to complete. So probably busy wait is not the answer. Oh, this is about the GitHub Actions, right? Let's actually talk about GitOps also. This thing is, I was thinking about the Helm values file purely from a GitOps perspective also.
Before you do that, you said busy wait's probably not ideal, but one can imagine a task as a notification task, which triggers a next GitHub action.
Correct.
To do the promotion of stuff.
Correct. I think that's a better way of doing it. If you're doing it in GitHub Actions, that's a better way of doing it. I mean, GitHub Actions is an example, but depending on your pipeline, you trigger whatever that pipeline trigger is. If it's a tecton, just
yes. No, GitHub Actions is just an example, but we can clearly do this kind of post request.
Correct. So, okay. Any other questions before we move on to what this means for GitOps, right? All right, so, there's a very, very sweet connection between Helm and GitOps operators. As you know, Argo CD has built-in support for Helm. So if you're describing your resources using Kubernetes resources, using Helm values file and a Helm chart, Argo CD will do the syncing directly using the Helm values file. So you don't have to worry about, creating other Kubernetes resources directly or anything like that. So that's how Argo CD operator works. It has built-in support for Helm. Same is true for Flux, right? Flux has a Helm release operator. So you describe your application using a Helm chart and a Helm values file, and boom, Flux will take care of ensuring your Kubernetes cluster state mirrors your Helm values source of truth. So this whole business of Helm-based experiment, I was thinking about it purely from a GitOps, from the perspective of simplifying GitOps, right? So what does it mean? Once again, let's go back to the values file. So if your values file looks like this, it means Argo CD is just creating for you a stable version of your application. If your values file looks like this, it means Argo CD is creating a stable version, it's creating a candidate version, and it's creating a GitHub, it's creating an iterate experiment, right? So because this is what the chart is asking you to do, and whenever there's a candidate, launch an experiment also. So Argo CD will create the experiment will run, the experiment will identify a winner, and either the current stable version will be the winner or the candidate will be the winner. Now what happens? Experiment ran, experiment completed, and this is still what it is. If you didn't change anything, that's how everything will live. But if you want the promotion to happen, we do need a task. So we need for this Helm-based experiments, we need a promotion task that can simply rewrite this values file. If candidate 1, all it needs to do is copy this candidate section underneath the stable section and delete this part. So there are some changes happening to the values file. Iterate experiment can do that using a well-defined task. And if nothing changed, in other words, stable version continues to be the new stable version, candidate did not succeed, it will simply delete this candidate section. And that will delete the experiment also, because no candidate means no experiment. Experiment is always coupled with the candidate. So that's how the deletion works. Now, this is about using a task for doing version promotion in a GitOps way, right? You change the values file that resides in some GitOps repo appropriately based on who the winner is. But you can do it either using a task, or once again you can do it using a notification, right? Once again you send a notification, some GitHub action kicks in, and it just promotes the candidate as a new stable version, or it just says nothing. I mean, it will just delete the candidate and continue to keep the old stable version depending on the result of the experiment. So in both cases, whether you are doing GitOps experiments or just plain old experiments, using regular CI/CD, you have the option of using notifications. Additionally, when you use GitOps experiments, you have the option of changing the values file directly using a task. This task is in our heads, just to be clear. It hasn't been implemented yet. But anyway, it's just an idea. So if you structure your Helm values file in a clean way like this, then we can also create the iterate task to do clean version promotion based on the schema of the values file. It can make some assumptions and it can do a clean version promotion.
But did you say that Argo CD is Helm aware? I mean, it understands the values file and the corresponding changes that come with it?
Yeah, it has I think it has a concept of Helm-based deployment. It has a concept of a customized-based deployment. So you can describe your application using Helm or using customize, and it will do the right thing. All right, so any other thoughts? Incidentally, Clive, I know we are meeting tomorrow. This was actually one of the things that I wanted to bring up, Helm-based experiments and Helm-based, in particular, Helm-based GitOps. Helm has some serious advantages for GitOps instead of, if you put some structure around how your application resources look like, you can get a whole lot of things for free out of Helm and out of GitOps operators.
Mm-hmm. Yeah, no, it sounds cool. So is the plan to provide sort of templates for users, like a Seldon template, a Kev sharing template, for the Helm chart, and then so users would take that and use that in their...
That would be the idea. That would exactly be the idea. So if we can create templates, the hope is that we can tell users, look, Seldon user, you want to do a validation, here's a template for you. It's almost ready to go. The only thing that is, we use a toy Seldon application in our template. The only thing you need to do is replace this toy Seldon application with your application, and boom, you're ready to go. That's what we would like to say. And that's what we would like to say for pretty much all experiment types, as much as possible. It may not be possible for every single experiment type, but for, let's say, we have to think through this. What are some common experiments that users will want to do, and appropriately create the template for those experiments.
Okay, cool. Yeah, that makes sense. I've got a quick question about the wait for condition. Is that like a JSON path, or is that just sort of specifically for conditions in the status?
It's actually specifically for conditions in the status, mainly because it uses kubectl wait under the covers for implementation. And incidentally, what you're asking uses JSON path as a long-standing open request in the Kubernetes community. Everybody wants exactly that, but it's not available. And so I just took the, what do you call, the easy route and just went with whatever was available. So
cool. Yeah, just finance.
Yeah. If you use something like JQ, I imagine you will be able to use any JSON path in there.
Cool. Yeah, looks good. I thought I'd just come in and have a quick listen to what's going on. So it's quite useful. So we can have quite a fast call tomorrow, as I'll be all.
Yeah. So yes, so the idea again is we want to create templates, and we want to create. It goes without saying that if you're an advanced user and you want to start changing the experiment template, of course you can do that. So there is no question there. But if you're not an advanced user and you just want to, you trust what is there in the template and you just want to get started quickly with experimentation and validation, even A/B testing, how can you do that? That's what this attempt is. And the attempt also is to make Iter8 play nice with the GitOps ecosystem, right? So GitOps ecosystem already has support, whether it is Flux or whether it is Argosy, it has a lot of support for Helm. And can we make it play nice in that ecosystem using Helm values file? That is the other attempt here.
Cool. So look, if people had their own metrics, would that also be in the Helm template? Or
this is a great question. So, by the way, there is a notion of a built-in metrics now. I don't know if you noticed that. So it
I've not seen that. So I heard you talk about it, but I didn't have a chance to check it out.
You didn't exist when you created your Selden, contribution. This thing didn't exist. So this is also something for you to check out. So let's go over that also. The way it works, built-in metrics, obviously you can only collect some basic metrics like latency and error rate. Iter8 doesn't understand anything else, but you can send queries to your application and collect basic metrics like latency and error rates and use it to validate your application. So, and that works using a task. So, Iter8 has a concept of tasks. So we actually have a metrics collection task. If you include this task in your experiment, and if you give it the appropriate, inputs and needs to send requests and collect values, collect responses, then boom, you suddenly have those latency and error rate metrics available for you. So your Selden application actually, that it has many things going on. It has a business metric, user engagement metric, and also latency error rate metrics. So if you just wanted, let's say you didn't want to use Prometheus and all that for latency error rate. You haven't set up telemetry yet. I don't know why you would not do it, but let's say for sake of argument, you didn't set up telemetry yet. Then this gives you a quick way of collecting basic latency error rate metrics. Of course, Iter8 doesn't understand user engagement. You created a metric called user engagement and supplied it. Otherwise, it has no way of knowing what user engagement is. So for that, you will need to create your own metric. Going back to your question, I think I would imagine, yes, when you have metrics that are your own, like user engagement, you would bake that in as part of the template.
Mm-hmm.
And that's minimally one of the things you would want to change when you change the template. If you have an A/B, definitely if you have an A/B testing experiment, and we create a fake user engagement metric, obviously you'll have to change it to your real user engagement.
So is there any issues around ordering then in terms of metric and experiment being created at the same time?
No, that's exactly what this readiness task is solving for you. So that's the whole motivation behind this readiness task. So it already includes a 5-second delay, by the way. So there is an initial delay here of initial delay seconds of 5. If you think you will need more than 5 seconds between the metrics creation and experiment creation or experiment start, certainly you can make this whatever you want. You can make this 30, for example. And that will, sequence they can get created in any order, but the experiment proper will not actually start until that, task succeeds. This task is intended to act as some sort of a gating mechanism so that, wait for all the required resources, make them available, and then start the real experiment. That's the idea.
Cool.
All right. So, any other comments on this whole Helm-based business? So, hi, you pushed the GitOps sample for STL. Do you have thoughts about this whole business of Helm? And you're also working on, I know you're working on OpenShift samples also. So do you have thoughts on potential simplification afforded by, Helm values file like this?
No, I think it looks good. It's pretty consistent with the way people are using GitOps, right? So in the GitOps tutorial I was creating, I was basically manipulating Kubernetes resource files directly in the repo. I think you're doing the same thing, but you're basically modifying values.yaml file and expecting Argo CD to pick that up and using Helm commands to deploy into the cluster instead of using kube control. I think it's slightly different, but it's very much the same.
Yeah. Yes. So you're right. It's the same concept. The only attraction for me with Helm is that we can impose some structure, like stable and candidate. That's the real attraction for me, which means if you impose some minimal structure like this, right, you can start writing tasks in Iter8 for promotion. So you can say when candidate 1, copy this over under stable. When candidate failed to win, delete this section. So we can start doing that without having to understand what that application is. For example, we can do the same thing for OpenShift, for Istio, for Selden, for plain Kubernetes, without having to understand exactly what that Kubernetes stack is and what that application is. That for me was, yeah.
Okay, sorry, I'll ask that one after you're done.
Yeah, I am done. Yes, that was the one.
No, so because on the point of promotion tasks, and I think your argument here was that this enables promotion tasks in a structured way by thinking about the stable and candidate sections. But one can also think about promotion, perhaps even more generic task, that is a Git task that knows how to modify files in Git, right? Let's say there's a YAML files. And then given let's say a path to things that you want to modify, one can imagine a promotion task to be built around that concept as well, right? And this could be a subtype of that, what you mentioned. So does that make any sense? Or?
Yes and no, right? It's all about where you're putting complexity, right? Mm-hmm. So it's here I'm imposing a structure and thereby making some simplifying assumptions. That makes the writing of the task simple. So correct. Yes, I think for example, if you're not using Helm, okay? So yes. If you're not a Helm, you don't want to use Helm. Yep. You still want to use Iter8 and you want to do GitOps. Then what you're saying makes perfect sense to me. That's exactly how I would do it. But if you're willing to use Helm, or if you're already a Helm user, then I think it is reasonable, more reasonable, to say put some structure around how you think about stable and candidate versions, think about experiments. Because if you do so, your experiment can look a lot simpler, right? Here, I can write a simple promotion task. Let's assume this is a GitOps experiment. And here I can write a simple promotion task, assuming we create it like this. Task, GitOps promote, let's see, with repo, Git repo, provide me the path for the Git repo and give me some token. I need to be able to update it. So let's say secret and Git token. And repo here. You can do this. That's it. Because to me, this is all your Git promote task needs to look like if you put some structure around you're right. We cannot call this promote. We have to call it Helm promote.
Yeah, exactly.
It is specific.
Exactly.
Yes. So it is not even Helm promote. It's really, strictly speaking, it's iterate, schema validated Helm promote. That's really what this
our opinionated
opinionated Helm promote. That's what it is. But if you have put some structure like this is how simple your Helm promote task will look like in the experiment. But if you didn't put any structure, now you're asking for, file. What is the name of the file? And what is the body that you want to see? I don't know, some JQ commands that you will want to incorporate for the promotion task. You have to think through that.
Unless there is also a way to do it in an opinionated way, what kind of structure you need in terms of files, etc., then that could potentially simplify what the task specification looks like in the experiment object. Right? So there is room for a structure there too, right?
There is room for structure there, but it will be dependent on stacks, I think. It will become domain dependent.
Possibly, yes. Possibly.
Here, I kind of eliminated the domain dependent also.
Mm-hmm.
I think you can do the same thing for even weights. You can even do the weights in a GitOpsy way. You don't even have to change weights. If you have, let's say, you have an Istio virtual service that is fixing weights, you can even do that in an opinionated way by saying, when you have something that is shifting weights, we expect this action. And this is how it needs to look. And it's a map, and baseline gets it. Candidate 0, candidate 1. This is how, your values file needs to be structured. So this way, if you want a GitOpsy change of weights, even that can be done very simply. Right? Same thing, same command. In the experiment, you just give within a loop, you just keep changing weights, and you just give the Git repo, and you just give the values file, right, the location of the values, and iterate do the usual thing, the weight shifting this way. So
it feels nice to see Collide here. It feels nice to see Collide.
Yeah, it is. Yeah, definitely nice. Yeah. Cool. So, when I started doing this Helm work, my idea was that we will do this for Kubernetes deployment, and we will do this for Kubernetes stateful sets. Stateful sets are for stateful applications, right? If you want to, create a new version, applications can involve, for example, updates to a database, and database is a stateful application. So my idea was that we will do this for deployment and do this for stateful set and go after the community. Because I noticed that Argo rollouts doesn't support stateful sets, and they have a number of people asking for stateful sets. And I noticed that Flagger doesn't support stateful sets. they have somebody asking for people are asking for stateful sets and ideas on how to make it work. And even Stefan saying, "Oh yeah, this is how to make it work. It looks good," but the feature is not there yet. So for us, this thing is damn easy to implement because you don't need to change fundamentally iterate in any way. You can write some Helm templates and you can say this is how you can do stateful set upgrades using iterate.
So I know that this would be applicable to the domain of plain Kubernetes, right?
Yeah.
Okay.
Plain.
No, I'm just okay. Yeah.
It's,
no,
it's plain Kubernetes. We can get away with plain Kubernetes because of our metrics collection task.
Right. No, there is no. I was just double checking that because as you were comparing, right, with Flagger, I couldn't help but think about what you said as an argument, as a talking point when you say why things that we are different from Flagger. This is this is a feature difference, and not only that, it's a feature difference that was in similar ones like this are easily done in our side because of how extensible and in general the framework is. So that kind of just trying to kind of work the muscle of differentiating against
The differentiation I would have gone with is 3 types of differentiation. One is stateful sets. We support plain and simple, right? The second is with plain Kubernetes, without the need to deploy telemetry and without the need to deploy service mesh, you can still walk away with some metrics. That's the second differentiation. And the third differentiation would be that we have a more, a proper view of GitOps. So, I would have done this with Argo CD also. And you have a real source of truth in your, it's not a real argument because Flagger supports, notifications. So I'm sure you can turn off promotion in Flagger and do the notification and, have a more truer GitOps using Flagger also. So I don't think it is a real argument to say that, we have the more purest view of GitOps. It actually works the way it's intended to work. Flagger doesn't work that way. I don't think it's true because you can use Flagger to do that same thing also using notifications. Argo rollouts does not have a concept of notifications. It doesn't support it. So it would be an advantage with respect to Argo. Just, having to do proper GitOps, making sure your Git repo reflects the baseline, the stable version correctly. I would say it's more difficult for Argo rollouts than Flagger.
So, Shri, regarding stateful sets, and did you take a look at why Flagger and Argo rollout are not supporting stateful set today? What's the technical challenge?
Argo rollouts doesn't support because Argo rollouts has this Argo deployment object, which is meant to be intended to be a drop-in replacement for Kubernetes deployment object and Kubernetes deployment object only. They didn't design Argo rollout for anything other than Kubernetes deployments, period. Now, with Flagger, I think what I saw, the last message that I saw was that you can modify Flagger to do this, but some basic changes are needed to the Flagger controller to support it. So I think somebody has to do it. It hasn't been done yet. That's all. There is a possibility of making that change, but somebody has to do the work. It needs to be done.
Yes. But if that's the case, I think Argo rollout and Flagger should be able to support stateful set pretty quickly. But as far as I know, stateful set are a lot more complicated than deployments to support, right? Especially with the persistent volumes. And also when you're doing a standing up or rolling upgrade of stateful sets, it's not as simple as just, incrementing the replica set. You need to coordinate it because sometimes when you have, let's say, a key value pair, store, and you can't just stand them up, one by one. There needs to be coordination. So the master slaves needs to be kind of coordinated before it's stood up. So there might be technical challenges that we need to think through before we say, we support for stateful set.
Absolutely, yes. In fact, Kubernetes describes how a rollout of a stateful set needs to proceed. An incremental rollout of a stateful set needs to proceed. So unlike Kubernetes deployments, as you rightly pointed out, Kubernetes stateful set incremental rollouts are more complicated. So I think Flagger also acknowledges that in the issue that I saw. Flagger says all those things, and they said, yeah, this is the right way to do it, but nobody has done it. So I think partly because it is not easy. I don't think it is that easy. It's possible. Everything is software, so it is possible to change Flagger to account for a stateful set, but it hasn't been done the last time I checked. Maybe things have changed since then, but it hasn't been done.
Okay, so one other comment related to Helm is that if I understand the chart that you were showing, some artifacts, for example, services, are only created when you define the candidates, right? The candidate service. I wonder if that's an efficient way to do things, because when you create a candidate service, it doesn't actually consume any resources in your cluster, right?
Can you repeat the question? I'm sorry, I missed it.
I didn't get to the part I was asking the question. I was basically stating that, if I understand it correctly, the candidate service is only created when this .value.candidate is defined, right? When you define a candidate, right?
Yes.
Otherwise, you will not be created. And also at the end of the experiment, you will remove the .value.candidate. So the service will be deleted by Argo CD.
Correct.
Okay.
Correct.
So maybe we might not want to have a lot of these kind of movements because services don't really consume any resources in the cluster. So you can just leave it in all the time without actually creating the candidate service at the start of the experiment and removing it at the end, because that's going to be imposing more load onto the Kubernetes API server.
The trade-off here is setup versus the periodic execution. And so from a simplicity perspective, it makes sense to put it here because the setup is the least. If you want to optimize things, then of course you could remove it from here, manually set it up ahead of time, and proceed. But I don't see this as a huge challenge per se.
Frankly, I don't see it either. But it kind of is ugly, right? You have a service, and it doesn't have a deployment backing it. And if you send some request to the service, it's going to fail because it doesn't have any corresponding deployment backing it. So it doesn't feel right.
That's okay. That's not, it's in my mind, it's more the need to take the extra step to create the service, which is a little bit out of band from running an experiment.
No, I think his highest point is we can just do this, right?
Yes, you can.
This is what I'm saying.
Oh no, there's no reason to do that.
I also think it's probably better. I mean, this is where you get to choose, right? It depends on your this depends on your setup. You get to choose how you structure your account. Definitely, you get to choose that. Personally, I don't think there is that much really involved in terms of tearing down a service, taking or a service or whatever.
Maybe this is the kind of thinking ahead. If you have a microservice that has more than just one component, and if you use more than services, right? For example, if you're using It's still virtual services or destination rules. There's a bunch of other, things that don't really require resources in the Kubernetes backend. For each experiment, you're basically standing up a lot of stuff. And at the end of the experiment, you're taking down a lot of stuff. It depends on, I guess, whether or not you want to optimize for the API server's load or not. Just a thought.
Agreed. It also is about what is running in your cluster, right? Do you want to keep things running? It's not running per se. What resources are present in your cluster? Do you want resources that don't have anything to do sticking around or not? So I don't know the answer, to be honest. I think my suspicion is it really depends. Different teams may take different views on this matter. That's my suspicion. And obviously you can do both. Yeah, just by changing that line, you can do both in the Helm command.
Yeah, I just kind of remembered that from our last conversation with John, he kind of mentioned that, at the end of the experiment, what are the stuff that you need to do? He seems to kind of hinting at trying to minimize the number of things that you're moving in your repo. So that's the reason I was kind of...
I mean, just to be sure, we don't have to do anything, right? Here, this is all included in the Helm chart. It's not a part of the values file. So this is how the Helm chart is constructed. This is very deep. This is kind of fixed for all experiments to come. So at the end of the experiment, the only thing that is changing is this. This file, you did this, and you did this. So that all changed. So
I think also the point is if this is the concern John has and he wants to minimize the number of moving parts, then you use a little bit different Helm chart for that environment. I think the trade-off is an end trade-off. It doesn't have to be defined by us. And I think from a opinionated way to do it, I would take the opinionated way that, when you run an experiment, you create these artifacts, and when you complete the experiment, you get rid of these artifacts, because that's kind of the cleanest thing to do.
Yeah.
Anything else becomes, your choice. Yes, you can create these artifacts and leave them. In this environment, if you're doing an Istio experiment here, the Helm chart has an option to create destination rules, for example. Could create them or not, because they can stay around. But in both cases, it's going to modify the virtual service. That would be in the Helm chart or not. Again, these are choices you make.
And you have the flexibility to do any of these things pretty easily. It's not that hard. You just take out that line if you don't like it. Yeah.
And we don't know, but if this is a large concern, this is a concern of many people when they look at this, then we have to, express clearly how the users can make this choice, right? Make this trade-off.
Fair enough.
All right. I think we're going to lose connection in a second.
Also,
there's a 1 hour
lose
limit.
connection, why?
There's a 1 hour limit.
No.
Oh, really?
Yeah.
Oh, Google Meet has the same type of restriction.
Yeah, it says
time?
it will end in under a minute. So.
All right.
Oh,
Well, congratulations. We managed to hit our first goal with these meetings, which was to have someone outside the team join.
I also recorded it.
yeah.
Good.
Fantastic.
Fantastic.
Oh,
Okay.
cool. Wow.
But there might be a lot of keyboard sounds, so I'm gonna see if we can do a better setup next time. But baby steps. All right. It says the call is about to end, so see you.
Yeah,
Okay.
I see that. All right, cool. Thanks, folks.